Here we are talking about arithmetic involving infinity. I strongly recommend that you pause this and try and go through and see if you can answer these if they exist. Do that and then resume and see how you did, okay? And for each of these, C is some positive real number. All right, so for this first one, if we have infinity and we either add or subtract some constant, we get still infinity, okay? If we take infinity and we multiply by a constant, we still have infinity. Now, here, if that were a negative, that's why we said C is positive. If this were negative, then that would become a negative infinity, which is fine, but for our purposes, we're just letting C be positive, okay? If we take C and we divide it by infinity, now this one's a little fuzzy because technically, remember that we're talking in terms of limits, not actual values, okay? So really we want to talk about what things are approaching. So if I take some constant and I divide it by infinity, well, since infinity is not a tangible finite, I mean, by definition, it's not a finite number, okay, we can't take something and divide by actual infinity, but we can look at what happens as we approach a constant, or approach infinity when we're dividing a constant. So any number I have, if I divide it by a larger and larger and larger and larger number, my quotient gets smaller and smaller and smaller, so this approaches 0, okay? If I take infinity and I add another infinity to that, then we approach infinity. And actually there's one more I want to add here because I did not before, but infinity times infinity is also still infinity, okay? This is the side where things get a little bit fuzzier. If we take infinity minus infinity, your instinct is probably to say that that is 0. However, it is not, okay? And let me give you an example of why it is not, because remember we're talking about limits. So let's say I have just an easy polynomial whose shape we know. So let's say we have the limit as x approaches infinity of x squared minus x. Okay, that's an easy polynomial. We know what that graph looks like. It's a parabola. It's opening upward. As x gets closer to infinity, we know that since parabola is opening up, approach infinity, we know this is going to be infinity. But if we just plug infinity in, we would have infinity minus infinity. And here, this is, which I really don't want to write that in between, but if I plug infinity into this, I would have infinity squared minus infinity, which is not 0 because we know from the graph of y equals x squared minus x that as x approaches infinity, this approaches infinity. Okay, so you might be saying, all right, well, then infinity minus infinity must be infinity. However, let's say we put a negative in front of that. What if we do the limit as, or switch our exponents? If we say limit as x approaches infinity of x minus x squared. Well, now we have a parabola opening downward, okay? And as x approaches infinity, this function approaches negative infinity. Even though plugging this in would still give us infinity minus infinity, this now approaches negative infinity. Okay? So infinity minus infinity is an indeterminate form, and we cannot do this. Can't do it. Now that doesn't mean the limit doesn't exist. That means we need to do something else. Like in these examples, we just looked at the shape of the graph. Okay? All right, next one, infinity divided by infinity. Again, your first instinct is probably to say, well, anything divided by itself is 1, but, fun fact, there are different sizes of infinity, okay? Meaning, infinity divided by infinity is not necessarily 1. All right, and let me show you an example. Let's say we have the limit as x approaches infinity of x squared over x. Okay, well, plugging this in, I'd have infinity over infinity, but I also know that this reduces to just x, meaning that here we have a limit of infinity. Okay, and likewise, we could flip that upside down and say the limit as x approaches infinity of x over x squared. Okay, and then that could be reduced to 1 over x. Well, as x approaches infinity, 1 over x approaches 0. So again, here we have x approaching infinity, but infinity divided by infinity is not equal to 1. Now, it doesn't even have to be 0 or infinity. It could be equal to like 2/5 or something like that. But either way, just having infinity over infinity is not enough to be able to evaluate a limit. So again, that's one that we can't do. Okay, infinity times 0. So for this one, you're saying, yep, those last two, I get it now. It's not as easy as I thought, but this one, anything times 0, I know for sure is 0. Unfortunately, wah wah, infinity times 0 when it comes to limits is not always 0, okay? It's another indeterminate form. And again, I'll give you an example, okay? Let's think about these that we just did, but I'm going to break them apart. So I'm going to write this as the limit as x approaches infinity of x squared over x, but I'm going to write this, I'm going to say this is equal to the limit as x approaches infinity of x squared times 1 over x, okay? Well, done separately, infinity squared is infinity. Infinity times infinity is infinity. And 1 over infinity does approach 0, which is what we said back here. Okay? So this is, if I just use direct substitution, I get infinity times 0. But the problem is, I already know from this up here that this is equal to infinity. Okay? So here is an example of where infinity times 0 is not 0. Now, let me put a little star on that. I'm not telling you that 0 times a number is not 0 in arithmetic, okay? Remember that we are talking about limits. So we aren't asking what is this exactly. We are asking what does it approach, okay? So we're not saying 0 times a number. We're saying something that approaches 0 times something that approaches a different number. Okay, but again, infinity times 0 is another indeterminate form. Okay, just like 0 over 0 that we talked about in the first section, where that means keep going. All of these are indeterminate forms. Okay, and for each of them, if you get one of those with a limit, it means you keep going. All right. Important. Keep going. If you get indeterminate forms, you keep going. Okay. And there are some other indeterminate forms that we will run into later, but for now, these are the ones we're going to be dealing with because of the infinities. Okay.